Hello students, I think you are safe and stay at home because this is the present situation. You know that world is in front of a great threatening of COVID-19 coronavirus. So I pray to the Almighty for your safety. Myself, Amit Chaudhuri, your chemistry teacher of class 6. I think all of you have already got the different PDF file made by our teachers for different subjects. Now today we are going to discuss about the matter, this chapter. So this is the introductory part of the matter. So first of all, we have to learn that what is matter. Matter is anything that means anything that has mass and it occupies the space or it has the volume. That means the first two criteria of matter, that it has mass and it occupies space. Now, not only that, matter, you can feel the matter by your sense perception. That means you can touch the matter, you can taste the matter, but that means by using your eyes, nose, and your finger, your skin, that means you can feel the matter. But for example, that air is around us. Air is a matter composed of different kinds of the gases. But you cannot see the air, but you can feel it. Air has mass and it occupies the space. So matter actually, it might be two different kinds, living thing and non-living thing. That means you can categorize matter into the two different parts. One part, the living matter, and another is non-living matter. Living matter means, for example, the human being, the trees, the plants, that means the animals, these are the living matter. And if you think about the non-living thing, say the chair, table, box, pen, pencil, books, these are the non-living matter. So generally, the characteristics of matter, that it has mass and it occupies space. And categorically, the matter is the two different kinds. You can categorize the matter into the two different types, living matter and the non-living matter. Now, the living matter, that actually categorize into the two different class. First of all, the plants, and the second one is the animal. And the non-living matter, it is actually characterized by two different parts. First of all, the natural matter, and the second one is artificial one. So first of all, the natural matter. You know that air, I have already discussed about this, that air is composed of the different kinds of the gas. So air is a kind of matter, but it is a non-living thing and it is a natural matter. For example, if you consider water. So water actually composed of two different kinds of the atoms. One is hydrogen atom and another is oxygen atom. So hydrogen and oxygen, these are two elements, two different kinds of the atom, and they combine with each other forms one molecule of water. So matter is composed by atoms and the molecules. So this is the example of non-living matter. But if you think about that, the artificial matter, that means what we can create by using the different raw materials. For example, the plastic. You know the polythene, the plastic. So actually the plastic or polythene, comes from the compound ethylene. You will learn later in higher classes, in class 10, whenever you will go to the class 10, then you will learn about the name of the matter, ethylene. So whenever different kinds of the ethylene molecules are polymerized, they form the polyethylene, simply polythene, and it is the origin of the plastic. So we know that matter generally categorized into the two different divisions. First one is that living matter and the second one is non-living matter. Now the living matter, it has the two parts. First one is the plants and the second one is the next one is that animals. And the non-living matter, it is categorized into the two different parts. One is the artificial one and the second one is the natural one. So you have to learn the different categories of matter with some example. Now what are the basic properties of matter? Two basic properties are there. It has mass and it occupies space. The space occupied by matter simply known as the volume. Okay, so this is the first thing you have to learn. So students, the first introductory part that is over. Now let us discuss about the composition of matter. Now the composition of matter, as we discussed earlier, that the matter is composed by the atoms and the molecules. And I think that all of you have some basic ideas about the atoms and the molecules. Atoms is the smallest possible unit of matter. So atom is the smallest possible unit of matter and atom is indivisible. That means you cannot break the atom. Earlier it is think about by the scientists that atom is indivisible, but now we know that if you can divide the atom into the three kinds of the subatomic particle: electron, proton and neutron. So we are not going to discuss about in detail about the electron, proton and neutron. We are going to discuss about the composition of the matter. So atom is the smallest possible unit of matter. So whenever the atoms of any element, they are combined with same kind of atom or the different kinds of the atom, they form the molecule. For example, when the two nitrogen atom come closer and they form the one molecule of nitrogen. And if you think about the different kinds of the atoms, for example, two hydrogen atoms, when associated with one oxygen atom, they form the one molecule of water. So molecule, this is also the smallest unit of matter. But if you think about that molecule, that is actually composed by the atoms. So atoms when combined with each other, but in some other different cases, you know that in case of the metal, all the metals, they are monoatomic. Monoatomic means they are single atom that represent a single molecule. For example, one atom of iron, it represents one molecule of iron. One atom of sodium, it represents the one molecule of sodium. And it is true for different kinds of the inert gases also. Helium, neon, argon, krypton, xenon, radon. These are the monoatomic molecules, and the single molecule that represent, the single atom represent the single molecule. So atoms and molecules, these are the basic composition of the matter. So, and the basic difference is that in case of the molecule, it has the independent existence. But in case of the atom, it has no such independence existence. If it is a monoatomic atom like the metal atom or the inert gases atom, then the atoms itself represent the molecule. So it is a different thing. So atom, you can say it is the smallest possible unit of matter. And when the atoms are associated together, they forms the molecules. So molecules also you can say the smallest unit of matter, but it exhibits all the properties of that kind of matter and it is capable of independent existence. So now we are going to discuss the characteristics of the particles or the molecules of the matter. First of all, whenever if you think about any matter. So it is composed by the molecules. Now these molecules are always in random motion. Random motion, that means you can say this motion is a zigzag motion, but it has a scientific term. You will learn later that this scientific term of the zigzag motion of the molecules in a matter is known as the Brownian motion. So, according to the name of the scientist, Robert Brown. So, this Brownian motion, or you can say the zigzag motion, that means haphazard. The molecules, they are actually running, they are moving in all possible directions. They collide with each other and they scattered with each other. They comes closer, hit each another and then spread or move in the different direction. It has no such specific direction. It moves in all direction. That is the zigzag motion. So all the molecules of the motion, they are in random movement in every possible direction. But you know that there are three kinds of the matter. One is the solid, another is the liquid, and third one is the gas. Now in case of the solid, that zigzag movement or the random motion, it is very less. In case of the liquid, it is much more as compared with the solid, and in case of the gas, it is the most. We are going to discuss it after few minutes, but before that, so first thing is that all the molecules of the motion are in the random zigzag motion. Next the next important point, that is the intermolecular force of attraction. So what is the intermolecular force of attraction? You know that the matter is composed by the different kinds of the molecule. Maybe the same kind of molecule or the different kinds of the molecule. But these molecules, they attract each other with a strong force of attraction. One molecule attracts the nearby molecules with a strong force of attraction. So this is termed as the intermolecular force of attraction. Now this intermolecular force of attraction, which actually holds the molecule tightly with each other. Now it's very obvious that if you think about a solid, in solid all the molecules are very close to each other. So the intermolecular force of attraction in case of the solid is most. But if you think about the liquid, say water, so here the molecules of water, they are loosely bounded as compared with the solid. So the intermolecular force of attraction between the liquid molecules are comparatively less than in the solid. And in case of the gas, the intermolecular force of attraction is almost negligible, and they are almost, I'm saying that one almost, they are almost free to move in any direction. So first one, the zigzag motion of the molecules or the random motion of the molecule. Second one is that the intermolecular force of attraction. And the third one is that intermolecular space, the space between the two molecules. That is the intermolecular space. Now you have to learn that some basic phenomenon which can be explained by this kind of the properties, that is the intermolecular force of attraction and the intermolecular space. Okay, let me give one example. If you know that, take a glass of water and if you add some salt or sugar and stir it well, so what we will observe? We will observe that the sugar particle or the salt particle, they actually dissolves in water, isn't it? But you notice that there is no rise in the volume of water. There is no rise in the level of water. That means there is no such increase in the volume of water after adding the sugar. So what is the reason behind it? The reason is very simple. The reason is that whenever you add a spoon of sugar or a spoon of salt within a glass of water and stir it, so what will happen? The size of this about the next part, that the intermolecular force of attraction and the intermolecular space. So if you add some sugar or salt in water, in a glass of water, then there is no increase in the level of water. So the reason behind it, the size of the sugar molecule or the salt molecule is comparatively very less than the size of the water molecule. So in between the water molecules, the sugar molecules make their own space. And why they can make their own space? Because the intermolecular space between the two water molecules. So in between the two water molecules, there is some space left. That is the intermolecular space, and the sugar molecule can penetrate that space and can adjust in between the intermolecular space. So all the sugar molecules, they actually adjust themselves in between the intermolecular space, and that's why there is no such increase in the level of water. Now if you think about, instead of the water and the sugar, if you think about that, you take a beaker and say fill that half of the portion of the beaker with some pebbles. Now if you place the sand, so it's obvious the size of the pebbles is much more bigger as compared with the size of the sand. So whenever you pour some sand inside that beaker which is half filled with the pebbles, then the sand molecules, they adjust in between the space, of that two pebbles. So that is the intermolecular space. Now if you think about, so another thing is that say the solid molecules, you know that solid have a definite shape. Any solid, books, chair, table, chalk, duster, whatever. So what is the reason behind it? The reason is that there is a strong intermolecular force of attraction in the solid molecules which holds the molecules tightly with each other, and very less intermolecular space. So most intermolecular force of attraction and very less intermolecular space, and that's why solid, it has a definite shape and a definite volume. But if you think about the liquid, any kind of liquid, say water or kerosene or whatever. Now, as I discussed earlier, that the intermolecular force of attraction in case of the liquids are very less as compared with the solid. And that's why the liquid, it has no definite shape, but it has a definite volume. If you consider 1 liter of water, now if you pour the 1 liter of water in a bottle, so it takes the shape of the bottle. Now if you place the same 1 liter of water in a jug, so it takes the shape of the jug. So the shape of the liquid, it actually changes according its container, but the volume is same. And you can pour the liquid from one container to another container because it can flow. Why? Because the intermolecular force of attraction in case of the liquid, these are very less, and the intermolecular force of attraction is also less. So the liquid can flow from one container to another container since it has less intermolecular force of attraction, and that's the reason that liquid, it has no such definite shape, but it has a definite volume. And in case of the gas molecules almost negligible intermolecular force of attraction, and intermolecular space in between the two molecules is very large. So that's why in case of the gaseous molecule, it has no such volume as well as it has no such definite shape. So today up to this much. Thank you.